Right, hello. We are Team 5, and our project was the Writable FAT32. So basically extending Lab 3 to handle the write functionality.
So our objectives for this lab was first, as he said, to extend the file system to be writable, and second, to add richer functionality to the shell by taking advantage of our new file system.
So we extended the file system API to basically create three main functionalities. It's to create a directory, create a file, and then remove a file. All of these take a path for creation and removal, and then you can also create a file with buffer if you want to create a file with contents.
We also, in order to write to files more than after just creating it, we implemented the write trait in vfat/file.rs, and as you can see here, it's just the interface for IO write. We implemented this function for our project to write to an arbitrary file at an arbitrary point in that file as well.
We also made some changes to the cache block device write sector, and basically give the writing functionality to cluster, chain, and fat entries so that we can write to them. And these called the write sector that we implemented. And also another challenge for this project was finding the SD card driver. A lot of the drivers didn't work, but Josh and I, we figured out a driver, and it was made for 32-bit architecture, and we made the necessary changes to fit it into our system, and we're able to get it working.
And finally, the end result of all this work was support for some new shell commands. So the ones that we chose to implement were make dir to make a directory, touch to create an empty file, cp to copy files and directories, rm to delete files and directories. And we also thought it would be interesting to implement the bash-esque redirect operators like the greater than sign and double greater than sign to redirect the output of one command into a file. We're going into the demo is that the timestamps for all the newly created files are going to be the same, and that is because obviously the Pi doesn't have a system clock, so we obviously aren't able to get accurate dates and times of file creation. So the first command that we would like to show is make dir, so to make a directory. So in this case, we're just going to try and make a new directory called test. All right, so if we look here, we can see that the new directory test has been made. And we can also touch files, as stated earlier. So for example, if I want to create an empty file in test called test/empty file, we can see that the file was indeed created.
And we also implemented the rm command, which essentially removes any file that you give it, and it can also remove directories and its children. So if you give it a path to a directory with children inside it, it'll kind of work recursively to remove the nested subdirectories and all the files within. And it doesn't matter if it's an empty directory or a file. So let's try to remove the test directory. So we just removed the nested directory with the file inside it, and we can also remove just files to give it a path of the file name. So yeah, there we go. Let's remove.
All right, and now we're going to take a look at the copy function. So you can copy individual files or you can copy whole directories. So for example, first we'll go into the solutions directory and the 0blinky/rust directory because it has a nice file for us to copy. So we're going to copy the file here and say cp blinky.rs into blinky.rs.copy. As you can see here, we have the original file, blinky.rs, as well as the copied file here. As you can see, they're identical. Additionally, if we can copy whole directories. So if we want to copy the solutions directory, we could do it as follows. We'll just call it saline. And obviously, there's a lot of files here, so might take a little bit. And as you can see here, it's done. So we'll go here and see that it has copied everything correctly, preserving the integrity of the files.
Okay, and the final command that we have is cat. So you can just use cat as regular, like cat a file, and then it'll output its contents. Okay, so if you do cat existing file greater than to another existing file, it will overwrite the file. And we can see that now Blinky has been written to test. Now, if we want to append to the file, we can do cat, the source file, and then 2 greater than symbols to our target file. And that will essentially append it to the end of the file.
And yeah, that was about it for our project. Again, we're Team 5 doing the writable FAT32 file system.